close-up captures and outcrops, right? Here I want us to think about in a 3D sense, away from that close-up view, what is happening? How do these reservoirs plumb, and what could be the implication, of the way, how could our correlation impact the quality of our model, the quality of what we know about the surface? How does that work? So right now I have a scenario where, let's say at a particular time, you have a muddy substrate, you have a meandering channel following suit at T2, and then you have another cycle that is, erosive mud, cuts off part of what was there before, and another channel at T4, and then you have another cycle of, muddy mud flows. This is typically happening in cycles most times. And let's say you have, by this time, let's say the slope has, in this southern part, the slope had become flatter. So you're able to get some kind of a splay, or what looks like a distributive lobe in this part of it. So what that is saying is that if I take 5 wells, 1, 2, 3, 4, 5, you can imagine what this looks like. And I'm speaking to Ross with in the hope that we're thinking about how we do stratigraphic or lithostratigraphic correlation, and how understanding of 3D reservoir architecture can influence how we do correlation. And then by extension, how our correlation will also help us in field development. If you are trying to drill a producer well versus an injector well, how do these things work? Starting from here, where we're trying to do correlation, okay? So here, you can imagine that if you drill a well at location 1, that's the gamma ray log, you see that location 1, you have 3 lobes, or 3 signatures there. The first one, finding upwards, second one, and the third one is blocky. Blocky because you are looking at a part of a splay or a distributive deposit. Location well 2 sees 2 of them, well 3 just sees 1 of them, and it's all because of the 3D architecture of these individual reservoirs, channels. Now, when you do a correlation, this is what it's going to look like. But guess what? If you hadn't known how these things plumb, trust me, you wouldn't even have you will probably just correlate this red, where my cursor is on well 1, to this one, and then directly to what you see in well 3. Meanwhile, in reality, these are the sands in terms of connectivity, in terms of, because you're going along the channel, okay? So what this is saying is that we have to think about 3D architecture in a regional sense, why we are doing our connection, why we are doing our correlation, because what we know will influence how we connect these individual gamma ray reservoirs, okay? Now, imagine a scenario where we now have, just a distributive system that just comes across and seals the whole thing. This is what it's going to look like also. Again, keeping in mind that these wells are not so close to each other, but the reason we're doing this correlation is because we already know that this sand, this is what it does in a 3D sense. But if you didn't know that, you will be correlating something else. Now, imagine an alternate scenario like this, where the sands are not going from west-east, but they're coming from north-south, and each of them is some kind of distributive or weakly confined system. You observe very quickly that the correlation has changed for the same well placement. So that is why we have to think a bit of, regional to sub-regional context, right? Why doing our correlation? These wells, are they along the strike line, or are they along, are they along the direction of travel of this deposit? Or are they, in what direction are they at the time that interval was deposited? Because if you do not have a hint of it, and you're trying to just say, I think this log motif is this log motif, which is lithostratigraphic correlation, there is a lot of issue that will come, because you will be connecting sands that in reality are not connected. Meanwhile, things are not, as you think they are. And that has implication. That has implication in terms of, if you want to drill a well and you want to drill another well to support or drain that same reservoir, you will drill well 1, for example, and then you go another few kilometers and drill well 2 in the hope that they are the same. But in reality, because the environment of the position or the trend is different, well 2 will not be able to support well 1 or will not be able to produce from this same reservoir. And this is part of why we need to think beyond just the gamma ray log for when we're doing correlation. And we also have to think in a sub-regional sense when we're thinking about reservoir connectivity, injector producer pair, when we're thinking about well drainage areas. It is all very important to keep this in mind while doing that, so that we're able to get a 3D plumbing of these reservoirs. Okay, so I'm trying to raise it because of time. It's 4 o'clock already, but I would like to, if there are other thoughts or questions on this, so that we quickly go ahead and round up, because this is the last section that we wanted to take. Faith.
Yeah.
Good evening, sir.
Yes, go ahead.
Sorry, my question is based on the previous slide. The sediment infilling. I want to ask, is there a cause for the discontinuity, or like the depression? What caused that kind of depression for another sediment to fill with low energy?
So that's a natural. It's a natural. It's a natural process. Just like when you're walking, remember the present is the key to the past, right?
Yes, sir.
If you walk on the road today, you have gullies, you have, like, call it gutters or openings. If you are in a terrain where there is a lot of erosion, like if you are from Anambra, for example, where you have gullies, where you have natural cuts like this, openings. So that's how it starts. We're saying that as at the time this was deposited, as at the timing of this deposition, this mass was probably, or this mass of rock was originally there. We probably had natural gullies or natural, depressions like this. And then much later, this was now filled by this other mass of deposits. The alternate would be that at initial time, there was nothing, there was no gully, but during the deposition of this other channel field, it came and created a cut into this pre-existing substrate, and then deposited this part. That's another scenario. So what we're doing is to use the relationship to figure out, did we have this in place before, or did the channel field create the cuts? That's the whole idea. So yes, that natural gully can be there naturally, just like if you go to some places, you see a depression, you see a gutter, that's how it works. And then sedimentation happens, deposits are layered and deposited, and they fill in that space, and then the cycle continues.
Maybe just to add, Faith, so when you have the initial deposition and the gully was not there, you could have the development of that gully by a non-depositional, or what we call erosive channel. So it doesn't deposit any new sediments into it. Because of the very high energy, it basically erodes and transports further down the materials along its paths. Then you can now have another system coming on top of that, but this time around a depositional system. So something like this. So the first one can come in, completely erode, and then another one will now come with lower energy and then deposits. That is how you can have this type of two system. So erosive and depositional channels.
All right. Thank you very much, sir.